We will now check end float. End float on a motor is when a shaft can pull in and out, basically wobble, so to speak. It's really more of a measurement of how loose the bearings are inside of the motor. If they're too loose and the shaft is able to move around, think of the case where the belts have to be aligned and you have one belt pulley moving back and forth with respect to the other pulley is a way of stretching and misaligning belts on a regular basis and pulling. The fix for that work is to replace the motor with a motor that's fixed, rebuilt, or new that does not have end float. Acceptable end float normally is kept about 2 mils. In reality, we really shouldn't see anything in a lab here at all. But the way to check end float is to use our dial indicator. Now, for this instance, I'm going to use a dial indicator a little heftier just so I have a bigger dial for you to see. For this dial, it also moves sideways rather than the previous version, which moves back. This again is just arranged for a side view of the camera. And ordinarily, we want this to be about half travel to get the best view of end float. And first, we have to lower this to match the shaft alignment. For that, we loosen screws. Loosen the screws to lower the alignment, but we want this to be pretty much in line with the shaft as much as possible. Once we do that, we move the plate so that our dial pushes part way, and we adjust the dial to give us a 0 reading. So in the case here, this is 0. Now, in an ideal situation, when I pull in a shaft, it should not move. When I push the shaft back in towards the motor, again, it doesn't move. That's a case of good end float, that there is no end float measurable. Again, if you see 2 mils of end float, and that's going from all the way out to all the way in, that differential, then we should replace the motor. Next, we will check for run out.